G'day guys, just did some work on this SD2000. This is the one the one in the last video I was working on. And if you remember, it its internal power supply was generating so much noise, and just basically the design of the detector is so damn noisy. So if you remember, we had noise on the input that was, God, I'm trying to remember what it was. I remember I was on, was I on 200 millivolts of division or 50? Can't remember what it was. I have to go back and look at the video. But at the moment, I've got this on 50 millivolts per division. I'll just give you a look at this. So that's 50 millivolts per division. Beforehand, I think we had noise all the way here, all the way there. So I've tamed the power supply down. We've only got a couple of spikes in there, but it doesn't seem to be doing too much detrimental to the detector. But we'll take this down, and you have a look at the waveform from here to here. That's 10 millivolts a division. That's pretty close to what you'd expect out of any of the modern detectors. It's getting pretty close to the mark. There is still noise there, but like I say, this thing's got its internal continuous running power supply. There's no way to turn it off during the receive cycle. I mean, you can do it. You can do a bit of a modification to a 4093 chip on the board, but the circuit sort of draws too much current, and it doesn't come back on quick enough on the transmit cycle to replenish and fill up the filter caps to right enough level. Just can't get enough current out of it. You really need to disable the positive voltage supply and put in a complete redesigned supply. You can't use these module things that are commonly available. They do not turn on and turn off fast enough. It'd be turning on and off halfway through the cycles where it's not meant to be. It will just cause a heap of noise and things will go pear-shaped. But that's the detector running at the moment. You can probably hear it. I'll just turn the volume up just in case you can't. So it's pretty quiet, and I'll just give it a test with 0.05 on the coil up here. That would be better out in the field with a dedicated mono coil, of course. On a 0.1 gram bit of gold. That's pretty good going. So that's running around about 2 megahertz, and we have some other crystal positions in here, and you'll see the frequency change on the oscilloscope as I change that. I'll bring it back in. But all that very fuzzy noise that we were seeing here has basically cleaned up. We've only got power supply spikes. They're a lot less than what they were. But like I say, it's impossible to get rid of them. But because they're all on both, well, basically the power supply, the noise from the power supply is on all the pulses equally spaced. And if the detector's adjusted properly, they should be ignored by the detector. But the spurious noise we had there before definitely was not. So, on big targets, I don't know if I've got any big targets sitting around here. I can grab screwdrivers, and that was a bit ridiculous. Well, piece of aluminium rod, I'm right up in the air there. So it's very sensitive, even on the cancel coil, on that crossover coil there. Not the best coil to use, trying to get distance, but you can't run a mono inside the house, especially on this. There's no cancel mode or anything like that, and it'll make a hell of a lot of noise. But yeah, this one's very, very successful. It seems to be working very good. I'm going to do a few more little things to it and clean it up a little bit more. And yeah, that just gets this out there so you can see that these older detectors can be cleaned up and made to work quite well. You can do this to any of the old SD detectors. Even the GPs, you can do a lot of work on those. You do work on the GPXs. You can do work on all these detectors. Even though they're a very good detector, they're all made to a price. And, in some cases, there are better components out there, better ways of doing things. And that's what we've been doing. Yeah, we've been getting a lot of work lately, probably because of the videos. And we'll just keep on keeping on. Anyway, catch us later. That's just a short, just to show you the improvements on this particular detector from the last video. Catch us.